In a stunning discovery that has sent shockwaves through the world of astronomy, the James Webb Telescope has just detected a group of galaxies that are much younger but more massive than anyone expected. These galaxies, which formed less than a billion years after the Big Bang, are challenging our fundamental understanding of how the universe evolved in its early stages. In today's video, we'll explore the implications of this groundbreaking discovery and what it could mean for our understanding of the cosmos. To better understand this, let's first look at these early stages of the Big Bang. The first period is known as inflation, which occurred 0 to 10 to the power of negative 36 seconds after the Big Bang. This is the theoretical time after the Big Bang when the universe expanded exponentially, quickly removing any irregularities and stepping into the scene to form cosmic structure. And then came the quark era, roughly 10 to the power of negative 36 to 10 to the power of negative 12 seconds after the Big Bang. And at this time, the universe was filled with a hot soup of quarks and gluons, which are the building blocks of protons and neutrons. Fast forward to a few nanoseconds, and we get the Big Bang nucleosynthesis, 1 second to 20 minutes after the Big Bang. This is when the first nuclei of light atoms, including hydrogen, helium, and lithium, were formed. And our main focus for today's video is the Dark Ages, 150 million years after the Big Bang. At this period, the universe was mostly dark and had no visible light, as the first stars and galaxies had not yet formed. It was not until the age of reionization, which was 150 million to 1 billion years after the Big Bang, that the first galaxies began to form, creating intense radiation that ionized the gas in the universe, making it transparent for light. Galaxies formed in this period were small and contained very low mass compared to the large, mature galaxies we see today. This is because during the Dark Ages, the universe still had a lot of light, so there wasn't enough energy to drive the galaxy. Therefore, the first galaxies formed at this time must have been quite compact and relatively simple in structure. They may have contained gas, dust, and hundreds to thousands of stars, and may have been irregular. Over time, they began to grow and become complex as gas and dust in the first galaxies and as they interacted with other galaxies through mergers and collisions. This eventually led to the many types of galaxies we see today, including spirals and ellipticals. So here comes the twist. According to the Big Bang, as we've already seen, there's supposed to be no galaxy that was formed in the first billion years. And even if there was, it's supposed to be tiny. But according to research published in the astrophysical journal Letters and co-authored by Italian astronomers, the James Webb Space Telescope just spotted a bright galaxy formed 400 million years after the Big Bang. And it's not just any galaxy, it's a massive one. Well, as you would expect, many scientists are now looking into this, trying to find an explanation. The JWST, which was launched in December 2021, enables us to see further back in time than its predecessor, Hubble. It catches pictures of distant galaxies with a bigger redshift, which are changes in the radiation from distant objects caused by the rapid expansion of the universe. If you're a bit lost on how it sees further back in time, here's how. In a vacuum, light maintains a constant speed of roughly 299,792,458 meters per second. Because it takes time for light to move from an object in space to us, when we look at those objects, we are effectively gazing back in time. This is because the light that we see has had to traverse this distance to reach us. For instance, if we look at a galaxy that is located 1 billion light-years away, the light that we see is the light that was released by that galaxy 1 billion years ago. But you may be thinking, what about all the dust in space? Well, it's possible for the James Webb Space Telescope to see past this cosmic dust that blocks our view of early galaxies because it was built to examine things in the cosmos at infrared wavelengths, which are used to survey the universe. It will also enable scientists to examine the features of these galaxies and learn more about the circumstances that prevailed in the early universe by detecting the dim light from some of the earliest galaxies that formed right after the Big Bang. Scientists have been shocked by pictures of brilliant galaxies with redshifts exceeding 10, equivalent to fewer than 500 million years after the Big Bang since the first JWST findings began to come. This one galaxy, in this case, has a redshift of 12. This means that the picture depicts the galaxy as it appeared roughly 400 million years after the birth of the universe. The redshift is approximated in these early phases of data analysis using photometry, which is a processing of the images themselves and may contain some mistakes. This is why these discoveries are classified as candidate galaxies by astronomers. Recently, the examined galaxy was given in a preprint with a redshift of 14 and labeled as the oldest ever detected. However, this estimate was later adjusted to 12. A more comprehensive examination of the light emitted by the galaxy, known as spectrometry, should offer the definitive measure. It's surprising to find so many bright galaxies in the first billion years after the Big Bang when only a small percentage of stars had formed. In an effort to provide an explanation for the findings made by JWST, scientists have come up with a number of different hypotheses. There is a belief that these galaxies were found by chance at a point in their history when they were producing the greatest number of stars, which is what causes them to shine with such an incredible amount of light. There's also the possibility that stellar winds in the region have swept away a considerable quantity of the dust that was around them, which has resulted in an increase in their brightness without causing them to expand in size. This would be consistent with the hypothesis that they have not grown in size. It's also conceivable that the JWST only looked at the teeny tiny parts of the sky where these anomalous galaxies are clustered together, and it's also possible that increased sampling won't uncover very many more of these galaxies. Both of these possibilities are plausible, but the former seems more likely. In the event that any of these hypotheses were confirmed, the conventional model would be maintained. However, in the event that the JWST finds a large number of galaxies that not only have enormous redshifts, but are also extremely massive, the concept would be proven wrong. The issue is, it takes a long time to build a galaxy, and even if you assume that all of the gas secreting in these galaxies is turned into stars, you could not produce such a mass in such a short amount of time. If what we're guessing is correct, then delaying the Big Bang is an option that makes sense as a response and would allow for a significant amount of time to go between the beginning of the universe and the formation of such enormous galaxies. If you think about it, it's rather exciting to be in a period when theories are being challenged. It's a great time to be alive. Besides, the James Webb Telescope was not launched to prove our theories right, but to challenge them. If galaxies such as this one were discovered to truly exist, it would suggest that the early cosmos was capable of producing structures that were far more sophisticated and vaster than we had previously imagined they could be. It would also raise quite a lot of new questions about the astrophysical processes that were at play during the Dark Ages, such as how these galaxies were able to develop and grow so swiftly in the absence of large light sources.